Hello students, this is my second lecture for the NET aspirant students of physics. In the first lecture, I discussed and worked out 5 specific problems of physics. Today also, I would like to pick up 5 specific problems and work them out. The first problem that I pick up is from solid state physics. First, let's read the question carefully. A metallic nanowire of length L is approximated as one-dimensional lattice of n atoms with lattice spacing A. So this is this is length L, this is a nanowire, so this is the center 0, this is L by 2 and this is minus L by 2, so the length is L. And there are n atoms with lattice spacing A, therefore we can write total length equals to n times A. Alright. Now you see the dispersion relation is given for this system, that is E equals to the dispersion relation given E equals to E naught minus twice T cosine of Ka. This is the dispersion relation. And then we have to find the density of states inside the system and how it depends on E. That we have to find out. And I'm sure that you have calculated density of states of free electron gas in 1D, 2D and 3D. You know how to do that. You just take a small elemental area of phase space, say this is say dx, dp, and then you know that h is a Planck's constant. H amount of area corresponds to one state, and therefore if you divide by h, then this gives me the total number of states in this elemental phase space area. And since you are talking about electrons, which has 2 degrees of freedom as far as spin is concerned, and therefore you have to multiply by 2, and then if you integrate over both the position and momentum, and then you get it as total number of states of the system, right? And this total number of states can be written as density of states and integrate over E. You get the total number of states. And therefore, if you can write this in this form, then you can extract the form or the functional form of E. Now in this case, what is important to us is this dispersion relation, because this gives me a relation between E and K, and therefore since you have dp here, it will give you h cut dk, and that dk could be expressed in terms of E or dE, right? So let's proceed. So total number of states integration GE dE is nothing but this is 2 by h integration dx, say minus L by 2 to L by 2, and then integration dp, which you can write as h cut dk, and therefore this should be equals to, so if you can bring it here, then it should be 2 by 2h cut by h into, if you integrate over, this is L and then integration dk equals to L by pi integration dk. Now you exploit the dispersion relation. Then if you do dE equals to minus twice t, then minus a sine of Ka and dk. This is equals to twice a t. Sine Ka is nothing but 1 minus cosine square Ka and then dk. And this equals to twice a t. square root of 1 minus, you know this cosine Ka is nothing but E naught minus E by twice t, and therefore this is E minus E naught square by twice t square, and equals to twice a t square root of 2t square minus E naught square by twice t equals to a square root of, and decay is there, of course, decay is there, a, and then this is twice t square minus E naught square dk, right? So this is d, right? And therefore dk equals to 1 by a square root of 2t square minus E naught square de. Okay, then we can substitute this in our earlier expression, this one, right? And therefore integration ge de equals to L by pi integration, now put dk, 1 by a square root of 2t square minus E naught square de, right? And therefore equals to integration. Now this L is Na, right? So Na by pi and square root of, and a square root of 1 minus, sorry, 2t square minus E naught square times de, and therefore this is nothing but G, right? If you compare, then this is density of states equals to a and a cancels, and therefore n by pi square root of 2t square minus E naught square, and therefore among the options this one is the correct answer. Now this I have worked out this problem very explicitly, but once you are working out the problem while appearing the exam, you just should not do this entire calculation. You just, for if it is 1D, then you just pick up integration dk and express it in terms of something d. Then you would know the functional form of the density of states with respect to E. If it is in 2D, this is 1D. If it is 2D, just take d2k and then express it in terms of something times d. You get the density of states in 2D. In 3D, you just integration d cube k and get it in terms of something d, okay, and then pick up the density of states. So while appearing the exam, you should not do the entire calculation. You just take integration dk and express it in terms of de, and the factor goes along with is the density of states. Okay, the next problem that I'm going to talk about is this. Let us read the question carefully. The following circuit, each device D, these are the devices, is an insulator with probability P or a conductor with probability 1 minus P. And the question is, what is the probability that a finite current will flow through the circuit, right? And therefore we have to ask the question, this so this is 1, 2, 3 and 4. These are the devices D, D, D. This is the first device, second device, third device and fourth device. Now if the current has to flow, this is one unit, okay, this is one unit and this is another unit. If the current has to flow through this circuit, then it has to flow through both this and this, right? Then I can ask the question that what is the probability that this circuit will not flow current, will not allow the current to flow. Then this should behave as insulator, this should behave as an insulator, and this also should behave as an insulator. Then if all three has to behave simultaneously as insulator, then the probability that all these three will be behaving as insulator is P probability into P probability into P probability. P probability equals to PQ. So PQ is the probability that these three, 1, 2, 3, these all diodes will behave as insulator. Then what is the probability that it will not behave as insulator? This is 1 minus PQ, right? And what is the probability that it will not behave as insulator? This is 1 minus P. If the current has to flow, then you have to find simultaneously the probability that this will not behave as insulator and also this will not behave as an insulator. This probability is this probability is this. Therefore, the simultaneous probability that both will allow current is this into this equals to 1 minus PQ into 1 minus P. So this is your correct choice. Okay, so this is the correct choice. Now next, I would go to the next question. It's a very simple question in solid state physics. This question is, what is the third nearest neighbor distance in a BCC lattice? Consider A as a lattice constant. You know that a BCC lattice is a cubic lattice structure with atoms at the corners, and in addition there is one more atom at the center. Okay, now if you think of this as the origin, or if you focus on this atom, then the first nearest neighbor, it is the very closest one, and therefore this is the first nearest neighbor atom, and next neighbor is this one. This is the second nearest neighbor, and then next one little far from here is this one. This is the third nearest neighbor. Then what is the distance between these two, or the third nearest neighbor distance? If this is A, and it is at right angle, and therefore this distance is square root of A square plus A square equals to A root 2. So this is the answer for this question. Okay. Now I move to the next question. This is a closed system having three non-degenerate energy levels with energies E equals to 0, plus epsilon and minus epsilon at a temperature T. Epsilon value is given twice kBT. Then the probability of finding the system in the state with energy E equals to 0 is, you have to find the probability that the system could be found with the energy equals to 0. Okay, so let me discuss it in a more general problem. This is a very common problem and it often appears in NET examination. Now suppose I have a system of n energy levels, 1, 2, 3, 4 and so on up to n energy levels. Okay, 1, 2, 3, 4, and this is energy E1, this is E2, this is E3, this is E4 and this is En. Okay, these are the energy levels. So this system, n energy levels are there. It's a closed system. And then if I ask that what is the probability that the system could be found at energy E equals to epsilon 1, and that obviously should be proportional to e to the power minus beta E1. You know this beta is a very standard parameter which is nothing but 1 by kBT. T is the temperature, it's a Boltzmann constant. Now what is the proportionality constant? And if I write P E equals to epsilon 1 equals to e to the power minus beta epsilon 1 by sum over e to the power minus beta epsilon I equals to 1 to n, then you see, so this is the probability that the system could be found at this energy. Now the system could be in any of these energies, and therefore if I sum all the probabilities like P of EU1 plus P of E2 plus dot dot up to plus P of En is nothing but, in the denominator you have I equals to 1 to n e to the power minus beta Ei, and here also you will sum e to the power minus beta epsilon 1 plus e to the minus beta epsilon 2 and so on, and this also sum I equals to 1 to n e to the minus beta epsilon 9 and is equal to 1. So total probability has to be 1, and therefore this weight factor is perfectly all right. Okay, so given the general description, let me come back to the question that has been asked here. So in this case we have three energy levels. Okay, this is 1, this is 2, and this is 3, just three energy levels. This energy E equals to minus epsilon, this energy E equals to 0, and this level energy E equals to epsilon, right? And I'm asking what is the probability that the system would be E equals to 0. Then obviously it should be e to the power minus beta into 0 by e to the power minus beta into minus epsilon, right, plus e to the power minus beta into 0, this energy level, plus e to the power minus beta epsilon, right? So this equals to this is 1 by e to the power, and this factor is 1, this is 1 plus e to the power beta epsilon plus e to the power minus beta epsilon, right? And since beta is 1 by kbt, and given that epsilon equals to twice kbt, epsilon equals to twice kbt, and therefore beta epsilon equals to 2. If I put it here in this, then this would be equals to 1 by 1 plus e to the power 2 plus e to the power minus 2 is nothing but 1 by 1 plus 2 twice cosine hyperbolic 2. So this is the answer. Now you see there is a choice that 1 by 1 plus 2 cosine hyperbolic 2. So this is the answer, and this is a very common problem. Okay, and then the last question that I am going to discuss here is this: the Green's function satisfying this relation. Okay, so this G is the Green's function. Okay, so don't be scared as it says Green's function. Okay, it is a function. The property is such that if you take the double derivative of the function, it will give you a delta function, right? With the boundary conditions given this and this. First check if any of these does not obey this boundary condition, then you can discard that. But if you look at it properly, then you will see that these boundary conditions are satisfied in all four possible choices of the Green's function that they have given. Then next attempt should be to look at this, to read this relation. This is the second derivative of this function is the delta function, and you know that if you have a step function, say this is x0 and this is say x. Now if you have a step function, unit step function, this is unity, then the derivative with respect to x would be, this is x0, would be a delta function. Okay, so this is known to us. A step function, derivative of step function is a delta function. Then if I have a function and I take the derivative of that as a delta function, then the first derivative of g should be a step function, right? Then if I take the first derivative of these functions and then see which one is perfectly a step function like this, then that would be the right Green's function, right? Now let me try to check the first one. Now the derivative of this, okay, between, say this is x0, between minus L, this is minus L, this is L, minus L to x0, the derivative of this is 1 by twice L into x0 minus L. And the derivative of this with respect to s between this is 1 by twice L into x0 plus L, right? And this is constant because x0 constant, L constant, so this is up to this, and this is larger, this is like this. And then what is this difference? This difference is 1 by twice L x0 plus L minus 1 by twice L x naught minus L equals to x naught by twice L plus half minus x naught by twice L plus half equals to 1, unity. So this is unity, and therefore it is exactly a unit step function whose derivative is nothing but a delta function, and therefore this is the correct choice for this problem. Okay, let me stop here and you try to work out these problems, and again I'll come back to you with the next lecture. Thank you.